database, the entire project database, that is your logic, your pictures or mimics or whatever, your field bus, whatever is designed for the particular project reside in this repository. And this machine also hosts the engineering tools for designing the particular software or hardware of that project. This is always a server-based node. The hardware is server loaded with Windows Server software. The software of Valmet loaded in this is engineering server client software. Next is the engineering client. In engineering client, only the engineering tools are loaded. There will not be any repository unlike engineering server. The engineering repository or the database will be unique and is residing only in the engineering server. So any engineering client designed for this project has to access the repository residing in the engineering server. So only the tools will be residing here. Tools for designing only will be residing in this. Hardware is, it can be a workstation or a laptop or a server machine. Windows operating system is loaded in this, and the Valmet software is only engineering client. Next is the information management server. The main purpose or function of this is for historization of data, which serves for your trend, alarm history, and reporting and analyzing. This is obviously a server node loaded with Windows Server OS and information server and tools software. Process controller is nothing but your distributed processing unit, which aids in controlling the process, scanning the IOs, field buses, everything, and it also acts as interface to the external systems through Modbus, etc. So here, the hardware mainly supplied for process controller is ACNCS or ACNMR. So here, real-time operating system is loaded and process controller software is there, which is nothing but your database designed using your engineering server. So we'll get into the specific functionality of each and every node. First is the engineering activity server tools and the management. Here you can see the DNA Explorer, which is one of the very powerful tools of engineering and maintenance. Through this DNA Explorer, you can design the field buses, hardware of any panel can be designed. You can design the mimics, and you can also design the field bus or Profibus using this single tool, DNA Explorer. It acts as an interface to all these design tools, and that with the applications designed using this tool altogether reside in a database called Auto Info database, and this is unique throughout the project, and there is only one database residing in the engineering activity server. This is not stored anywhere else. So at any point of time, the database is residing only in the engineering activity server, and it is the latest. So all the logics and other mimics and hardwares, whatever is designed through this tool is available under repository, and through repository it is downloaded to the main applications. So another important tool is your picture designer. In picture designer, like what you see is what you get. So it has got an extensive library of three-dimensional devices, tanks, pipelines, and other components related to a process. So it is a powerful tool in the engineering set. So here we'll see how the database built by us, how it is traveling throughout all the segments. First, the database being created, the logic or the hardware being designed or the IOs, whatever designed using through the DNA Explorer, which is residing in the repository, that is the Auto Info database, AIDB, and it is unique. This is residing in the engineering activity server. When you give a download command from the engineering activity server, this database is first downloaded to VU. That is your backup node. All the packages from this database are sent to the backup node. So what is a package? A package is nothing but a collection of application. Here application packages. The first letter A1 corresponds to the control room. The next two letters corresponds to the package name. CR is your control package. A1 is your alarm package. O is the operate package. Similarly, we have several packages. H is your history package. L is for links. P is for processor. So all the packages are getting moved to your BU when we give a command. From there, it is also simultaneously pushed to their respective nodes. Where it has to be pushed is defined in the BU. So the moment you give a download command, which package has to go to which node is defined in our backup node. So automatically, only those packages are pushed to the specific nodes. For example, operator station needs only its corresponding operate package and its own operator station package. So only those things are pushed to the operator station. If it's alarm node, only the related packages are pushed to alarm node. So the processor package will not be pushed to your alarm node. That specific definition is provided in the backup node by a file called group file, du underscore grp file. So when any download command happens, the file is read and only the corresponding packages are pushed to their respective nodes. That is about engineering server. Now we'll see about the backup server unit. This specific node, as we saw in the previous slide, it stores the application and the real-time parameters as defined by us, like how frequently it has to be stored, whatever we define, that is stored in our backup nodes. The backup node disk, the hard disk of the backup node not only stores this database, but also the configuration of other nodes. What slots are configured in other nodes? What applications are to be run in other nodes? Those things are also defined in the hard disk. So at any point of time, when any ACN or the distributed processing node, which we call ACNMR or CS, any point of time when there is a hardware failure, it is very simple. We need to just replace the hardware alone. All the relevant uh, files are loaded from the backup node. All the system files required for booting the ACN is also loaded from backup node, and they all boot up. And after they boot up, they take the relevant application packages also from backup node. So when there is any power failure, if it is a Windows-based node, it will automatically boot up, like operator station or alarm station. It will automatically boot up through their Windows operating station, and they take the relevant packages from backup nodes. But in case of ACN, it boots up through the help of files residing in BU, the system files. And once it boots up, it takes the application packages and it becomes completely operational on its own. It doesn't depend on the availability of BU. So here we'll see the concept how backup node works. This is on a normal scenario or a normal operation. From engineering server, the packages are downloaded to the backup node, and the ACNs work on their own. They don't depend on BU node for any software. They are in running condition. In this scenario, imagine that our ACNs are down. In this case, what happens? Any ACN, like you are freshly booting up a ACN or you have replaced an ACN due to some hardware failure or something. So the ACN is put on network. First thing what happens is it will search for a DHCP server on the network, because the ACN does not have any boot related or system related file to boot up on its own. So it looked for a DHCP server on the network. The BU, which acts as a DHCP server, just respond back that I'm the DHCP server and my address is this. So once this ACN get to know that there is a BU which has given back the address, it will request for booting. So give me a boot time address, I would like to boot. Once the ACN requests that, this BU will check in its own files whether this particular ACN is listed or not. So after giving a boot time address, it will check whether this particular ACN I should give the files or not to boot. That is configured in BU system file. This ACN is listed or not. So once it finds, it transfers all the files to the ACN. So now the ACN is taking all the Linux files for booting. So once it has taken all the Linux files, now the system related files, hardware, all these files are taken from BU to the ACN. Now the ACN is completely functional on its own. So this is functionality of DNA operate node. We have seen EAS backup node. Now we can see about the DNA operate. The DNA operate tool is very effective here. And even we have the history playback option available here. This is our control panel with lot of buttons which can be linked to open a main picture. This is a quick overview of the main picture which is linked here. And these are the recent alarms. So using this powerful tool, we can uh, arrange the windows, loop windows or the main windows in whatever fashion we want. We can zoom or pan, and this desktop itself we can save as a particular save it with a particular name. So whenever any operator changes, they can just click it and open. So the loops being continuously monitored by them, regularly monitored by them, that automatically opens. They need not navigate and open. So this is a very good feature where where a particular operator generally monitors particular things. All those loops and loop windows can be open, and uh, uh, this view of the desktop itself can be captured and made it as a favorite. So whenever you open that favorite, all the loops existing in that open in that state. Here we can see the history mode indication. This yellow color indicates that this particular picture is in history mode, that is in the playback mode. What happens is when you put this, we can analyze the SOE sequence of events happened in that particular time, during that particular time, and we can just drag and drop anything to the trend window and we can see the trend here. So there are several dynamic features associated with the DNA operate tool. Even there is a diary button where you can enter the operator events related to a particular happening, so that when the next operator comes in next shift, he can view the diary of events for that particular event. It is like some notes being given for the next shift or for any particular event which had happened. Feature from collection 16 onwards is the interlocking feature. So at one single click, we will be able to see when we click loop window, there is a button called interlockings. Through a single click, we'll be able to see the interlockings of that particular loop. So this feature is available from collection 16 onwards. And this tool you are all maybe familiar with this tool already. This is a DNA tracer tool which is used for trending and analysis. Here you can see the trends by drag and drop along with the events also. And this by right click you can navigate to the diary window or to the SOE pages also. While talking about info, there is a very brief session on info, maybe in a day or two. So we'll see briefly about the reporting features available in our info server. This is advanced alarms and events. So through this, we can just see through this DNA report alarms and events report, we can see the standing alarms duration for that moment, how many alarms are standing over a period of time, and operator response, like how long operator has taken to acknowledge a particular alarm, or how long it has taken to go to normal state. All this can be analyzed through this alarms and advanced alarms and events feature available in our My Community portal. So this feature is part of our info server, and this is extended through network to all the operator stations or all the stations available on the network, and this can be extended outside network to office through a router. So this is our alarm list window. So our alarm list window consists of the type of alarm, date and time. We'll have the millisecond resolution here. It also carries the priority, type of alarm, the process area. This is the loop tag from which you can right click and navigate to the loop also. And this is the loop name. This is the event, what event, whether it has crossed the higher limit, lower limit, all those things. And this disappearing time or when it has gone back to normal, that time is also indicated here. And this is the acknowledgement time. So here, as we talk about the reporting and analysis tools of our info server, it is a very powerful tool where on one right click, you will be able to open several things. When you right click and go to a DNA trend or event trend, you also get the events on the trends. And on one click of that, you can get into the deeper analysis. This also gets linked to the My Community, and it shows the list of alarms, like when it has occurred, the alarms for this particular um, signal or tag, that is also displayed in our My Community page, and it can also go to the DNA report. Any report linked to that for the particular signal also will be opened on right click. So this is for this web-based portal is a very effective tool for the management to take decisions about their productions and cost involved, all those things. So we'll get into the Walmart DNA communication. Walmart DNA communication is name-based communication. That is, every signal is addressed with a particular tag name. For example, how it works. Any particular, like any loop or any ACN requires value of a particular signal, or there is any internal reference, how it calls. What happens is it is only called by name. There is like it has to call with a name, and this name is unique throughout the system. There cannot be same names used in this system. So this is called name-based communication. So all the signals are addressed with a particular name. So whenever a query is pushed into the system for this particular name, only the node which has that particular name responds back. So this we call multicast to unicast, which is explained in future slides. I'll just explain this in detail in future slides. So the in the concept of Walmart DNA communication, like how in general communication happens in Walmart DNA, between PCS to PCS, cyclically it happens based on the control cycle defined by us in the logics. Between the operator station and PCS, the PCS cyclically updates the values to the operator station. But from operator station to PCS is only on demand. Whenever there is a command output from operator station, only on that time the commands will be taken. So this is called on-demand communication. And these are all like happen between PCS and between PCS to ops. It happens cyclically based on the cycle time defined in logics. So like control task and control cycle. So what is a control task? Control task executes all the function blocks defined in a PCS. For every loop, we would have defined a particular control cycle. So within that control cycle, the control task has to be executed. So within that time, it has to scan all the IOs within the defined control cycle of 10 millisecond to 64 second. It has to scan all the IOs. It has to execute all the function blocks, and also it has to publish or post the outputs to the IO bus. So within this control cycle, the control task is executed. And within a particular ACN, there may be several control tasks with several different control cycles existing. So this is a very general brief about how IO field bus communication happens. So this is our ACN. Each ACN each ACN will serve as the field bus master. So it is connected to the field bus clients through IO bus controllers. So one single field bus can support 16 IO group pairs. Every IO group pair is provided with the IO bus controller. So the values are read by the IO values are read by the IO bus controller, and IO bus controller in turn communicates with the ACN. And ACN communicates back to the IO field bus IOs through the IO bus controller, which is the IBC. IBC is the IO bus controller. So as we were discussing about the name-based communication, how it happens, this multicast and unicast updates help in the name-based communication. So first, here you can see the DNA operates servers and the clients. Clients are nothing but they take the operate server sessions. Operate server can have multiple sessions. This is all license based. One session means it can just open on its own PC. If we offer several sessions, it can be opened as clients on multiple PCs. So there are several operate server and clients sitting in Valna DNA network. So when any Valna operate server wants to see anything, like when you open a picture on runtime, so all the related signals value should be populated. So how that happens? When a particular signal is queried, like who has that tag LIC100, this query is passed on as multicast query to all the controllers in the network. What all controllers existing here, it is passed on to all the controllers through the multicast query. But the controller which is having the value alone will respond back to the DNA operate server. So this response is called unicast update. So whenever any query is passed, it is always multicast to many. And whenever a response is given, this is unicast. Only the ACN or the node which has got the value of that particular name will only respond, and henceforth this this communication will get subscribed, like this name value request is subscribed, and only this ACN henceforth will communicate with this particular server for this particular signal. And then what happens, this server has got the values, and this server in turn has to give it back to the clients. So that also happens through the multicast. It gives the values what all it fetched for that particular picture through multicast updates to all the clients. If we go into the Valma DNA networks, generally these two topologies are followed by us. One is the turbo ring, and the other one is the RSTP tree-like solution. Turbo ring, we have a very good recovery rate, that is less than 300 milliseconds. In case of RSTP solutions, the recovery rate is slightly longer, but generally ring topology is preferred in network where it is very much distributed and the nodes are not many, but the locations are very much distributed. In those cases, we'll go for ring topology. RSTP solution we adopt in case there are several nodes. There are n number of nodes existing in a particular control room. In those cases, we generally go for RSTP solutions. So mainly in bigger plans, we go for this RSTP solution. We shall see about the DNA IP addressing. Before we get into this in detail, we can see what is a subsystem. In Valma DNA, everything is Sorry, I'll just go to the slide. Can I continue? Like everyone is able to hear, no? Am I audible? Can anyone please respond? Is it audible to everyone? Shall we proceed? One of you please respond. Yeah, I hope it's fine. So we shall see about the DNA IP addressing and the subsystem. Here everything, before we get into any project, at the start of any project, we'll do this IP addressing first. In IP addressing, what happens is, first we have to decide the number of nodes in any particular system what we are designing. For example, we take a particular plant. We first see the number of nodes present in the plant. And based on the number of nodes, we'll classify them into several subsystems. Every subsystem can have only up to 50 nodes. There can be only 50 nodes in every subsystem. And for every 50 node, we should have one backup node. So one backup node for every 50 nodes is mandatory. So first we will segregate them and decide on number of subsystems required for a particular plant. So now we have decided on the number of subsystems. Now we will group it together. Like all the HMI nodes generally will put under one subsystem. And each subsystem will have its own token. Each subsystem will have its own token address, hardware address, IP address. So this token address is like old concept which was used in old versions of Valmet system. Still that is getting continued here. And this token should be unique throughout the particular plant. There should not be any token clash within a particular system. And this hardware address, all these are already frozen. This Excel sheet is already frozen. We have several subsystems, and for every subsystem, we have this hardware address, IP address, token address, everything frozen. So based on that, we'll just only populate the names of ACNs and names of nodes in this particular subsystem configuration. That is the IP addressing configuration. So at any point, there should not be any hardware address clash or token clash in the system. So this is an example of a very big power plant where you will be able to see several units here. Unit 1, Unit 2, Unit 3, Unit 4. There are 4 units, and there will be several common systems also existing in this plant. So how we form subsystems here? We are having a subsystem A, B, and C within a particular unit. A may be for HMI, B for SGTG, and C for BOP. Like this, we'll split up and organize the subsystems, and every subsystem will have one BU. So all the ACN related files and PC related files also will be existing within that particular BU. This BU will host files of only that particular subsystem, not of any other subsystem. So all these subsystems are connected together in a L3 switch. This switch is having flex links for redundancy. At any point of time, one link will be active and the other link will become active when this fails. So similarly, we'll make this for all the units and common system. And all these things are connected to a layer 3 switch, which is also having flex link. At any point, it can take up any link. One link will be active. As I mentioned earlier, this is called DMZ zone, where we keep our information server or whatever the external interfaces are there. No, all this will happen through this zone only, which is our demilitarized zone. This is a zone which will interact to the outside world. So the info server also will be placed in this zone, and it can provide the reporting and analysis functionality to the office network through the web browser. So there is a router. Through this router come firewall. Through this only, all the third-party links are accessed. All the OPC informations, everything is accessed through this router come firewall to the office network or to any other subsystem, like any other third-party systems. So this is in general about big plant, like how we design a big plant. So as we have seen in detail about like all the nodes, I can just show you the configuration of all the nodes. Like, are there any doubts till now? Are there any doubts till now? Shall I show you the configurations of nodes?
Yeah. Hello, madam.
Yes, ma'am.
Actually, I want to know about the communication happening between IBC and IO groups and the ACNs.
Okay. Between the
We are
IB,
having
continue. Between the IBCs and IOs, our proprietary Walmart DNA communication through some IBC, within IBC and the ACN is TCP.
yeah.
Yeah.
So I want to know. Actually, in our system, there are 3 LAN connections in IBC.
In IBC,
Yeah.
we will not have 3, no? Maximum of
2 are one
ACN.
is red, one is blue, and the other one is yellow.
That is in the back plane.
Yeah. I want to know what is that for.
See that backplane communication, no, health status are exchanged. The health status between the redundant IBCs are exchanged to the backplane. That is the rack cable.
It is
The other
connected to.
it is between the redundant racks.
Okay,
Between the
means we
redundant
in one
IBC.
panel we have 4 racks, so it is connected to 1 or 3 or 1 or 2 rack.
Yeah. It is connected to the corresponding redundant track. The IBC, no, there will be
Yeah.
redundant IBCs. Among the redundant IBCs, this interlink cable will be connected. This
So,
interlink cable, uh,
so is there every IBC is redundant in every panel?
no, it
Is
is
it
not so.
This means
It is
you
not
use
so.
OBS.
It is
then?
based on the design.
OBS.
Okay, but then
Yeah.
every IBC it's a yellow cable, so that's what is a concern.
Maybe
Because the
all they would have in your plant, everything may be redundant. All IBCs may be redundant. See,
okay means
in
in
some
four
cases,
if
in
we have
SG and
four
all,
what?
see, in MFT cases and all, there will not be redundant controllers. In those
Yeah,
cases, you will not be seeing this. Yeah. In
okay.
other
In
cases,
normal
it will be
panels
all
like BOP
IBCs.
panels.
Yes, it will be there.
Okay, so we have four racks in a panel, so it means two are redundant and two are main.
Yes, correct. IBCs are redundant. Not the, we cannot tell all the IOs are redundant. The IBCs are redundant. There can be
Okay, IOs
non-redundant IOs also.
in a rack means IOs cannot be redundant and IBC can be redundant.
Correct, yes, correct.
Yeah, this is this possible? Means one two IBCs having different IOs.
Yeah, that is also possible.
Okay, so it may be the case like that.
It is possible.
Yeah. Okay.
The two other cables are for your field bus. It can
Field
be
bus.
either, field bus. And those
So how
cables
it is
will be
connected?
finally connected.
It is connected to ACN, I think.
Yes, correct. Yes, correct.
Okay. And madam, I want to know, like we have two BU server, AB01 and AB02. What are they for?
Okay.
We have two different BUs.
I was explaining, no, the subsystem concept in IP addressing. So
Yeah.
there may be systems used in your plant. One BU
How?
will be addressing one subsystem. Like other
We have
BUs for the. Please come again.
actually it has been divided into three subsystems like BOP, TG, and FSS.
BOP,
TG,
SG,
turbine,
and TG. Huh?
and SG, and the other one is SG. Three subsystems.
Actually, subsystem, what we call here is collection of 50 nodes. SG and TG put together, you may be having a collection of 50 nodes. So that is
Okay.
called a subsystem. BOP put
Okay. So
together a collection of 50 nodes. That is second subsystem.
okay, मतलब one BU is for SGTJ and one BU is for BOP.
Yeah, it would have been like that. I need to check your configuration. But for every 50 nodes, there will be a BU. That is called a
50
subsystem.
50 or 15.
50.
Okay.
Yeah.
Okay. And madam, there is also a repository is there, library is also there. What is that
Okay.
for?
Libraries is also, see, these are all called workspaces. For
Okay.
keeping, for storing your templates and other files, no, you can use other workspaces. But
So
repository is the one which communicates with backup node. So you
so
will be
if we
able to
download something,
download the loop.
yeah. It's
Only
like a
from
default
repository you will be
workplace.
able to download. Yes,
Okay.
correct.
Okay. And
Yeah.
if I have downloaded something in engineering station, it will go to
Uh-huh.
backup server first, है ना?
Yes,
And
correct.
then how it will go to ACN? Because ACNs will be running, so how it will go to ACN and how ACN will fetch the new data?
The moment you give download, it goes to backup node, and backup node checks its group file. in group file which package corresponds to which node. The moment it
Okay.
checks, automatically backup node pushes it to that particular ACN.
Okay.
The
And
package is pushed
if
to that particular ACN.
okay, so if one ACN will run at once, so it will push it to the main ACN and the redundant one will take it later. Or what? At once both
No, no, it is
ACNs will
not
be
like that.
updated.
Yes, yes, at once both ASINs will be updated. It is the
Okay.
application package. So at any point of time, main and redundant should have the same application package. It is pushed to both the nodes.
And madam, there is a
नहीं क्या फट ज्यादा है नहीं हम लोग का बहुत पर्पसफुल नहीं लग रहा बहुत पर्पसफुल नहीं है
Any other question? Shall I proceed with node configuration? Okay, I'll mute all and proceed with node configuration. So I have a demo server here. Through this demo server, I'll be just showing you the different applications in Valmet and for different nodes, how do we configure, what all the important files, what all the things to be taken care, all those things we'll discuss now. So the moment we install Valmet DNA, this DNA folder gets created under D drive. So this is our default location for Valmet DNA installation. Under DNA, we have three things called. First one is CA, which is the control activity. Second one is EA, engineering activity. Next is IA, information activity. The other one is OA, operations activity. Since this is my demo server, I have loaded all the modules in it. Like operator is also there, engineer is also there, info server is also there, backup node is also there. Since this is a demo server, I have got everything installed in one particular server. But if you see in your plant, the specific node will have only the specific application. If you go to any engineering node, we will have only the EA. And for the info server, we'll be having the IA. For backup node and OPC server, we'll be having controls activity. For operator server, we'll be having operations activity. So these are the basic folders which get created when we install Valmet DNA. Now we'll see how basically to set up a particular node. After doing a fresh installation, we have to set up this system file. This system file is nothing but it tells the list of programs running in this particular node. And this system file is always addressed with hardware ID of the particular node. So this particular node, for example, some operator station it is, we have to see in the DNA addressing what is the hardware ID for that particular node. So the name of this file has to be hardware ID of the node .sys. After that, we'll open it in a notepad and we can see the configuration here. So this file will be available for each and every node existing in the system. This is called system file. It defines the particular node, like what all the applications running in that particular node. So we'll be having the bus, system bus. Like we have A, B, C. the particular system bus should be defined here. And this is the hardware address of the node. This is the token of the node. And this will carry the IP address of the node. Generally in your plant, it will be like 192.168. All these things to be fetched from the IP addressing list. So this three will be unique throughout the plant. There shouldn't be any clash. So we configure this. Next thing what we configure is the name of the backup node of that particular subsystem. That should be mentioned here, AB01 or AB02. This is the node which serves for this particular node 61. And here from here starts the slot definition. We call it as slot. Every application which is running is called as a slot. So network communication unit. This is a very important slot which should be running in each and every node. Without this node, any Walmart DNA communication will not happen. So this is the backbone of Walmart DNA communication. This slot will be running in all the nodes irrespective of ACN or Windows based node. Every node will have this slot. So this always will be slot number 16. So when we open, slot number 16 will be always network communication unit. After that, we can define our all the slots existing for a particular node, sorry. Always slot 3 and slot 4 corresponds to operator station. So when you go to when you are setting up an operator station, like if it is some spare PC or some operator station failed, you can, when you are setting up an operator station, you have to ensure that slot 3 and slot 4 are configured. This is for your operator station. This is called CDMGR and QMGR. QMGR is the client and CDMGR is the server. So any operate server will have one server and client. This is one session existing in that particular node. If you want that particular operate server to be accessed from other nodes, then this session alone will be extended through licenses. By default, we'll have one session, one operate server. So this is the title of the operate server, A101, A102, like that. Here it is B102. And these are like default settings we can take from the template. So this is about your operator station. Once these two slots and the network communication slot is configured, your operator station is done. You're done with the configuration of your operator station. Next we'll see about the alarm station. Alarm station, it is always slot 6. So slot 6, you can name your alarm station. It is either A1. This is the control room. A1 you can give for your unit 1, B1 can be for your unit 2, C1 can be for your unit 3, something like that. First letter is your defines your control room. Next, A1 stands for your alarm station. So this title you will be giving. This is all standard, we'll copy from template. So with this, your alarm station slot is configured. Now we'll see about backup node. Backup node is always defined in either slot 1 or slot 15. These slot numbers we are keeping on maintaining as standard so that it will be easy for troubleshooting also. So always don't go for different slots. You can use the same slot numbers mentioned. 3 and 4 for your operator station, 6 for your alarms, 15 or 1 for your backup node. So in backup node, what we configure? The title of the backup node. And this is the DHCP IP which we were discussing. So this has to be set up. This backup node, this line, since this is my local demo server, I have not given this. Otherwise, in your plant, if you see, This will be uncommented and you will have an IP here. So once you define this DHCP IP here, your BU will be able to communicate through this DHCP IP during the first time boot of your ACNs. So through this DHCP only first time file communication happens. So this is about your BU. This is about particular system. There is an application called slot controller. So whatever you define in this file will be reflected here. This is an interactive tool to start particular slots. So if you see, we have defined 15 as BU. So we can see the backup node here. And always number 16 is your network communication unit. This should first start and become running. Then only any other slot will start up. Otherwise, there is no startup in any other slot. So first thing we have to ensure is your PC is having proper IP and it is connected to network. Once that is done, your NCU will start properly and normally function. Once this is functioning, all other slots will start. If any of this slot is not starting, we can see how to troubleshoot. So after defining this system file, now we shall see like in detail about the main important files related in any configuration of a particular node. First we'll start with simple one, the operator station. We have seen slot 3 and 4 are for operator station. To define that, we have to go into the OA activity, operations activity. Inside operations activity, we can go to the use folder. Under use folder, we have a folder called CPU. So this is the folder under which all the related executable files are located. So whatever operator station we are configuring, the related files should be posted in this location. So how do we do that? If you're setting up a client or a new node, go to templates. You can take the CDMGR and QEMGR conf file. These two are the files which are required for operator station. So copy these two files under use CPU. The moment you copy the files, rename them to cdmgr.cpu and qemgr.conf. So these are the two files which drives your operator compact. Here you can see the name of the operator station. Here you have to update the name of the operator station, name of backup node. And these are the packages which it will take from your backup node. Since this is my demo server, I have given all the application packages. But in your plant, it will be either A1 or B1, whatever unit it belongs to, only those packages will be taken. US, this is the package which contains the standard system displays. U is the standard package which contains all the custom-based displays for A1U. That is all your pictures. A1US is your standard picture library, like all your control panel, alarm display, all these displays are standard. All these displays will be residing in package A1US. All the custom-based displays will be residing under A1Q. So all these packages should be loaded by this particular operator station. So this is definition of your operate server. After defining your operate server, now QEMGR is your operate client. This definition also to be checked. So here what important things you have to notice. This is the operator server name. So the name has to be edited here. So once you do this, you have set up the operate server and client. This is about configuration of operate server and client. Now we'll see about the backup node. Now we are going to the backup node. When you want to set up a backup node, as I told, first do the system file, configure slot 15 or slot 1 as backup node and backup slot. Then you have to go to the CA folder. Under that CA BU folder, inside BU you can check the templates. There are two important files called GRP file and sys file. These two files forms all the definitions of that particular plant. So this two we have to copy and put it under this location. So these are those two files. If my backup node is AB01, name has to be AB01 underscore GRP, AB01 underscore sys. If this is AB02, I'll give AB02 underscore GRP and AB02 underscore sys. Now we'll see what to configure in this file. First we'll do with the system file. This system file is different from the 61.sys system file. That 61.sys file which we saw under DNA folder, this defines the slots, the programs running in that particular PC. But this particular sys file defines the systems which are taken care by this particular BU. So these two system files are different. This system file is for exclusively it is for your BU backup node. So if you open this file, you will be able to see several definitions like this. So each of this correspond to one particular node. We will see this one. You may have a pair of ACNs existing in your plant, AP01 underscore main, AP01 underscore reserve. So all those things should be defined in this particular backup node. If the definition is missing in the particular backup node, this backup node will not give the related files when the ACN is booting. When any ACN requests for a boot, backup node checks with this and then only it gives the files. So at any point of time, all the nodes existing under this backup nodes control should be populated here. So these are all like default templates, how we should define. For MR, we will be defining like this. For ACNCS, we'll be defining like this. For MRG2, the definition is different. So we have to take, this is the hardware ID of the particular ACN. And this 162 number corresponds to the field bus. If there are two field bus existing in particular ACN, it will go like this, 162, 164. So this corresponds to field bus number 1, field bus number 2. In some of your panels, if there are more than 16 IO groups, you would have extended the field bus because one field bus can take care of only 16 IO groups. If there are more than 16 IO groups, you would have extended to another field bus. So this is the second field bus. So like this, we have to define all the ACN pairs and all the nodes, PC nodes also. So if this is my operator station, I have to define like A1, O1, B1, A1. This is alarm station. This is my operator station, B1, O2. So I have to put the hardware ID also here, the name of the station also here. Likewise, we'll be defining all the stations in this backup node. So at any point, if any communication is not happening in your plant, like ACN is not booting or operator station is not fetching the displays properly, or operator stations, first of all, the operator station slot will not start. In all those cases, you can just check if these definitions are properly defined. Next is the group file. Group file is nothing but it tells the backup node which package is pushed to which location. See, since this is my demo setup, it will be having a different thing. Actually, in plant, what happens? AP01 should go to AP01 underscore main and AP01 underscore reserve. Like this, we will be defining all the packages. So in case of like a single ACN, we'll be defining only that particular ACN. So like this, all packages should be listed here. So based on this definition only, any download will happen. In case in my demo, I can push many packages to a particular virtual ACN. So I have configured with virtual ACN BP02, BP04, BP03 in my machine. So all these packages I am pushing to only that particular ACN. But in a plant, it is not the case. We have separate packages for separate functionalities and separate ACNs. So every package we have to define, it has to go to downloaded to which ACN. So whatever we define here, that only goes. If there is any mistake like this, if any ACN name is defined wrongly, this package will be moved to this particular ACN only. So this will be a mistake. So this we have to be careful which package has to be downloaded to which ACN. All that should be properly defined here. So we have seen about the backup node. Now we'll see about the licenses. None of the slots, either operator slot or your alarm slot, will not boot unless even your ACN will not boot unless the license file is loaded into the system. So we'll see where this license file exists. This license file should be put under the view folder. Generally, all the licenses are made or generated with respect to the particular hardware ID of the engineering server. Suppose this engineering server is existing in your system, we'll take the MAC address of this engineering server and bind all the licenses to this MAC ID. So this MAC ID should be existing in your system for the license to be functional. Generally, all the licenses are available under this folder. The DNA shared law CFG. Here you can see EA. Wherever EA is mentioned, this is for your engineering license. So this engineering license is bound to your MAC ID. So at any point, whatever is any additional feature required also is bound to MAC ID. We cannot edit anything in this license file. Even a removal of a particular character or addition of a character will corrupt the file. So this engineering license is required for engineering the system. Next, you can see the OA, operator licenses. So all these licenses also should be present. We can see three components here: monitors, pictures, and sessions. So this is like how many monitors you can connect, how many pictures you can open. Like pictures will be always star, n number of pictures, and sessions. If it is 2, 3, or 4, based on that number of sessions can be opened. And this is for your controller. We'll have the field buses and the start of the ACN. This session should be required. So at any point when a ACN is rebooted, it checks, BU checks for ACN name in the license file also and its system file also. When it finds a match only, it will allow the ACN to boot, but by providing the required files. Otherwise, the ACN cannot boot and become operational. So for OPC also, we need license like this. So all these licenses, once they are put up in this folder, DNA shared law CFG of engineering station, this has to be copied to BU. So once you copy, this file will be available here. So this file, BU should know, unless this file is available in BU backup node, none of the ACNs will boot. So when you are replacing or setting up a new backup node, you have to like keep in mind all those points about the license existence in BU, about the system file, group file, and about the ACN files. So we have seen about the Windows nodes. Every Windows node will have this system file under its DNA. Then what about ACNs? Because ACNs are not Windows based, and ACNs do not have any operating system by default. We cannot put any file. We cannot load any file into the system. But there is a compact flash where we will be loading only the token hardware address and multicast of that particular ACN. So the particular ACN's token hardware address and multicast will be put into that particular ACN. So when the ACN try to boot, and another important thing is also put, that is the project ID. See this file is also put into the flash of ACN. Here you will be having a project ID. Whatever written in this project ID, no, this should match with ACN. Inside DNA's CABU folder, whatever existing, this file should be same in the ACN also. Then otherwise also ACN will not boot if it is not matching. So there are 3-4 things to be taken care when ACN is not booting. First is this project ID should be matching. Second is in BU sys file, ACN definition should be existing. Third is that in BU, no, DHCP IP we were talking about, that IP should be mentioned. So in BU's adapter, if you see under DNA underscore PB, in addition to BU's IP, 192.168, this is BU's IP. In addition to this, it will also have this IP, DHCP IP, which we defined in the slot controller. So if this is not existing, PU cannot act as a DHCP server. So this also to be checked. If any ACN is not booting, we can go to BU directly and first check whether DHCP server is existing. If it is existing, then the request from ACN should reach BU automatically. Then next step, even though request is reaching and ACN is not able to boot, then we have to check the system file of BU whether the ACN hardware ID name is defined in it. Once all these things are there, ACN should definitely boot. Now ACN may be getting all the general Linux-based files for booting. Now project-specific files, it will take from BU. All those files are present here. For any Windows-based node, we are putting the system file under DNA. But in case of ACN, we have to load all the system files under this particular location. All the files related to AP01, AP02, or all the ACNs, the system files will be loaded here. Now I'll show a sample system file of ACN. So this is this ACN file will also have the MCU slot running here, and it is the ACN slot, and slot 2 will be the field bus slot. If you have additional field bus, then next slot also will be running. See, the field bus IPs are also defined here. These are all field bus IPs. So this is system file of ACN. So like this, for every ACN, for main separately, for reserve separately, like that, if you have 30 pairs, 60 files of system files of ACN will be available under BU folder. We have to copy the files under BU folder. So this also to be checked. So this is all about files configuration. Now you can check, like ask if there are any questions. Yes, sir. 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 Mm-hmm. Sir, Mac bound with Mac ID of engineering server, sir. If your BU node clashes, then you can replace with the new BU node and copy the same license there. This particular license consists of all the nodes existing in that particular system. But backup node doesn't require a license to start. Backup node slot will start without any license. So when any backup node crashes, you can replace the node and copy the same license file. But if your engineering server clashes, you have to approach us, sir. Engineering server cannot be rebuilt into a different node because it is bound with the MAC ID. We have to generate a new license for that. Okay, sir.
Hello, madam.
Yes, ma'am.
Ma'am, what is A1U and A1US?
Ma'am, these are packages. U stands for use.
Okay.
U packages for your use. Use is nothing but your DNA operator. So all the pictures designed for that particular project, like for the particular project, you would have designed many pictures, no? All those will be
Yes.
residing under U package, A1U package.
Okay.
A1U, yes, is your standard displays. Like your alarm
Graphic.
page is a standard display. Your control panel is a standard display. Even browser is a standard display. Your loop windows are standard displays. All these will be available under A1US packages.
Oh, okay. Okay.
Hmm.
Thank you, madam.
Okay. Any other queries?
Just only input this and the agent update that. Listen and only I will process input.
Are there any questions from TSN co side, please?
You getting on the mention in the
You may unmute yourself and talk.
Madam,
Kindly mute yourself. TSN may talk. TSN has raised the hand. You may talk, sir, please.
if it raise my hand, then
In case TSN doesn't have any questions, we will move on to CVP NALCO office. You have to unmute yourself. Kindly do not switch on your mobiles inside your conference rooms. Part of this noise disturbance will come. See, echoes are happening. Do not keep two systems too nearby. Any questions from TSGenco or CPP NALCO? G. Ravi Kumar, Sai Ram, Suresh Kumar, you may come out please with your questions. Others kindly mute yourselves. Others kindly mute yourself.
Madam.
Yeah, sir, please go ahead. Yeah, sir, please ask your question.